It only makes sense that the International Space Station cannot maintain its normal operation without the help from Earth. All supplies are delivered here by cargo and crew transfer spacecrafts. But in power supply terms, the ISS is absolutely autonomous. The only source of energy for the gigantic orbital station is the sun. The station's EPS consists of solar arrays, which, as you probably know, are located both on Russian and American segments, and batteries that accumulate energy to be used when the ISS is eclipsed by Earth. So when we fly on the solar side, solar arrays send energy to the batteries, and when we pass through the shaded part of our orbit, these batteries feed the station. The solar arrays of the American segment. The station has 4 wings like this. Another 2 wings are looking down at the moment. Unfortunately, the camera cannot catch all of it at the same time. Here we can see a piece of a US radiator and the solar arrays of the service module. There they are. Unfortunately, we are looking at their rear now, meaning the silicon solar cells are on the other side, receiving solar energy. And here are the solar arrays of the service module again, only from another angle. We have recently entered daylight. This solar array is actively generating energy and passing it to batteries. Right now, we see one of the control laptops of the Russian orbital segment, which is used to send commands to various systems. I wanted to show you the solar array orientation system framework that we use to manually reposition solar arrays. Crew members' interference with this mostly automated process is only one way to control the solar arrays, because generally all of that is performed automatically or by specialists on the ground. But the crew has a possibility to take over the control if there's a need for that. We are going to have another look at the solar array wings of the US segment from the SO-1 module, which is almost prepared for a spacewalk. Let's get to a window. I'm showing you as much of them as I can. These are the solar array wings of the US segment. They generate most of the energy for the station because they have huge surface area. But some of the energy also comes from the Zvezda module solar arrays, as I told you already. As the station orbits around our planet, its angular position changes all the time. So the solar arrays have to track the sun to stay at 90 degrees to the sun rays. That's the job of the solar array orientation system. We call it simply SOSB. It can be activated by photosensors or the guidance, navigation, and control system. In emergency situations, the crew can position the arrays as needed manually via a control laptop with a special framework that I already showed you already. So the system is quite simple and quite reliable. The solar panels track the sun and always position themselves at 90 degrees to it. That is whenever it is possible. And the energy of photons is transformed into electricity and sent to the batteries, like I explained to you earlier. The total energy received from all of the solar arrays, both US and Russian, is enough to power everything on the station with something left to spare. You can get a rough idea of the size of these panels from what I was able to show you through the windows. It's kind of like a small football field in space that flies together with us. And now let's get to the cupola, which is connected to Node 3, to have a look at the solar arrays of the Russian segment, US segment, and the American Cygnus spacecraft, which is docked to the station at the moment. See that? See that? That is the solar panel of the Cygnus, a cargo spacecraft that has recently docked to us. And here we can see the Soyuz. It also has its solar arrays unfolded, and the energy generated by them is sent to the mains of the station. This is the Soyuz of Yuri Ivanovich Malenchenko. And let's look at all this beauty one more time. The power supply of the station is just one example of international collaboration on the ISS. Normal running of this unique space laboratory requires cooperation of all the countries on the mission. And first of all, it concerns Russia and the United States of America. The control of the International Space Station has two sides to it, meaning there are two basic aspects that make the control of the ISS possible. On one hand, we are talking about the US gimbals, which produce gyroscopic effect, and on the other hand, we have the thrusters of the Russian orbital segment. Gimbals cannot work without thrusters, and thrusters cannot stay in control of such a huge station all the time. So Russian and American segments depend on each other very much, and it forces both us and our American colleagues to collaborate in space, to find common language, and even sometimes even make friends.